Hello everybody, this is Mr. Kusaj. We're back with another lesson. This is 1-5, Parent Functions and Translations. A parent function is the simplest function of a type, right? There's a few types, but here we're just going to go over the simplest one, okay? So the first one is the constant function, right? That's when you have f of x equals a number, any number, okay? So for example, this looks like the graph of f of x equals 2, 1, 2 up. So this whole line is y equals 2, or f of x equals 2, right? This is 2, this is 2. For all the x's, y equals 2. In fact, there is no x here, just a number, right? F of x equals a number. Straight line across, okay? Then we move on to f of x equals x, right? So this is another way of looking at this is y equals x. Whatever x is, y is the same thing. So if x is 1, y is 1. If x is 2, y is 2. If x is 3, y is 3. So this is a straight line, but it's not horizontal, it's diagonal like that, okay? That's f of x equals x, all right? That's called the identity function. Okay, this one you've seen before, f of x equals x squared, right? So x squared, what happens is the graph curves up. So think about it, whether you put a positive or a negative x, you're going to get a positive y, right? Positive 1 gets you positive 1 for y. Negative 1 gets you positive 1 for y, right? Whenever you square a negative, you get positive. So that's why we never come down here for y, because whatever you put in here, it's going to get squared and become positive. So that's why we're only positive y. So x squared looks like this. All right, that's the quadratic. Then we have the cubic function, and that one looks a little bit like a snake. Now keep in mind, so far, right, all of them, for x equals 1, y is 1. So when you sketch these, at the very least, right, it's hard to sketch them. But at the very least, you should go through 0, 0, and 1, 1, right? 1, 1, 1, 1, 1 to the left, 1 up, 1, 1, 1 to the left, 1 down, 1, 1, right? So and then make it look like a snake shape. Okay? So the cubic looks like that. So what we're saying here is if you ever come across a function with an x squared in it, you know it's going to have this shape, right? You don't know where it's going to be, or if it's going to be upside down or right side up or to the left or right, but it is going to have this shape. If you ever come across a function that has x cubed, it's going to look like this. These are the parent functions. Okay, there's a few more. This is the square root function. Notice that the square root function starts at 0, 0, and just like the other one, there is a 1, 1, right? Also notice that we cannot put a negative x in there. We're not allowed to put a negative x. That's why there's nothing to the left here. We can't put a negative x there. So the square root starts at 0, 0, and just goes up, okay? Now, if you think about it, it's going to go up forever. It looks like it's slowing down going up, but it's still going to continue to go up. So the x's are infinite and the y's are infinite, right? The range going up starts at 0 and goes up forever. The domain starts at 0 and goes to the right forever, okay? It doesn't like level off and come straight. No, it actually keeps going up. All right, next one, the reciprocal, the fraction. 1 over x. Now, as you know, with these kind of fractions, you're not allowed to have 0. Look closely. There's nothing at 0. It's not touching x equals 0 anywhere. X can't be 0, right? So again, when x is 1, then y is 1, 1 over 1. When x is negative 1, 1 over negative 1 is negative 1. So negative 1, negative 1, right? And then just draw coming close to the axes, but not touching the axes, because that'd be like touching 0 and being 0, and you can't have a 0 there. Okay, 2 more. So these are, what are we up to? 6? These first 6 are the most common one. Once in a while, you might see the absolute value function. Okay, f of x equals x in absolute symbols. Absolute sign is the 2 bars, yes? So notice that if I put, remember how the absolute value works? If it's negative, it becomes positive. If it's positive, it stays positive. So if x is 1, then y is 1. If x is negative 1, then it comes out as positive 1. So y is 1 again. So it's like a mirror reflection, because when it comes out, it's going to be just like this one. Even though you're putting negative x's, it's going to be just like this one, only on the other side. Okay? So think of it like the V shape. Straight lines here, 2 straight lines here. 2 straight lines, 2 straight lines. Okay? And the least popular one is this last one. This is called the greatest integer graph. Okay? Now, f of x equals x. Now, if you look carefully, it's like hard brackets, but it's like bold here, like 2 bars, and then like brackets comes in like that. That's greatest integer. Okay? So just copy this. We'll talk more about it tomorrow. But there's a really good example that you're very familiar with that's this graph. Okay, that's it. I just wanted you to be introduced to these graphs, and in the next set, the translation parts, we're going to move these graphs around. Meaning that, what if you have x to the third plus 1? What if you have 2 times x to the third? What does it do to this graph? So that's transforming it. Okay, that's tomorrow. So until then, good night.